Hey guys, welcome to episode 22 of the Trading Signals Coding Session series. Today we're going to be debugging the incoming signals workflow. We are still disassembling the first iteration of the Trading Signals project. We are working on the second. We already coded, but we haven't tested the incoming flow. The outgoing flow was tested at the previous episode. So let's get into this. Here we have the outgoing stack or workflow. Signals are coming from here, into not trading simulation, open storage, network start, WebSocket clients, and they jump into the network. Oh, sorry, it's not web. From here, network start, they go into something that is not here, that is the HTTP client, network client. So this is the outgoing workflow. The incoming workflow is over here, where we have the network client. Okay, it's going to receive the message through here. It's going to get it into the network interface. So from here, we are going to start debugging, okay? Signal received. And we go deeper into candles and trading signals, and that's it. So, yeah. But instead of running this here we're going to run the bot task server 1, the one that is sending the signals. So we will need another task server here, number 2, for the bot that is receiving the signal. So I'm going to clean all this. We will not need this, nor this. And the trading simulation can be more or less okay there. But what we are actually going to need is peer-to-peer network interface that is in social trading SA modules. So projects, social trading SA modules, peer-to-peer network interface. Okay, so no need for this one. And from here, incoming candles. Sorry. No. Okay, we are going to stop it here and debug it inwards. We are going to discover the next modules when they stop here. So our network is running here. So we're going to run this guy that is going to send the signals and debug here. Then we're going to run the second guy. And debug here. Okay. So we just need the task first of the second box to be running in order to receive the signal. So we're not going to run this bot, just not for now, but we're going to run this one that is the one producing the signal. So let's go. We have hack the simulation so that it jumps from 10 to almost the end to make it quicker. In fact, I can run this directly on Node.js because there's nothing to change from there. But anyways, here we are. Now we have the signal that is telling me which is the file key, how I'm going to get this. So let's see where this takes us. Okay, so we are in here, signals received, and receive a signal from the network, and this is what we're going to do with this. First, we validate the signatures. Okay, this is the same function that we were running at the network node, so it should work exactly the same. Yes, there's no validation message. So now we have just received what we have just received are not trading signal, but a signal message that represents the file key needed to locate blah blah blah. Okay, so from here we're going to go to the file to the open storage, and with this signal key, this guy should be able to get the signal content. Okay, so we're going to get in here. I believe it's going to work because we already tested this, but anyway, I want to refresh my memory. Where are we? My guess is something didn't work. That's why this is stuck here. Yes. Got a first problem. Load file of undefined. Incoming signals. Open storage client. What this is saying is that this is undefined open storage client. Where are we executing now? Okay, so we receive another signal. Oh no. We didn't receive a shit. Okay, so why is this undefined, this guy? There's some property missing. Or no. So this is initialized here. That means if this guy doesn't have a bot, social trading bot reference parent, then it's not going to come through here. So we'll have to run this again. Anyway, it's not running. And Probably we are going to stop this guy, going to run it directly on Node.js so it goes even faster. So regarding this guy, we will run here with debug. Okay, I don't see this coming through. Let's check this again. Debug. Does it have a bot? Yes. Does it have social trading bot reference? Yes. This is a yes. And available storage is no. Okay. So it seems that in order to load this stuff, we don't need to go that far as having an available storage, because available storage is only going to be used by the bot that is sending the signals, not the one receiving the signals. So probably this line is not needed. Okay, so this will solve the problem of the stuff not being defined. Now we send the signals just by running this. This was pretty fast. Signal received. Probably we can skip this one next time. Or we will keep it so that we know when there's a new signal. Okay. Now this has something. We can get in. File name, file password, file content. So available storage. This is undefined. Okay, and here there is a problem. And the problem is that the bot that is following the signals, the bot that is following the signals, there is no declaration of available storage. In fact, yeah. Where is this available storage coming from anyway? This is not correct. That available storage is the available storage only useful when you're saving your signals, because that's the storage where you can save your stuff. But for retrieving, for loading a file, what we have here is storage container ID. That is what is going to tell us that is going to get us here. With a storage container. Wait a second. Wait a second. When we were saving the signals, we save them at all the available storage containers defined for that bot. Because the idea is that if some of them is not available when you want to retrieve the signal file, then you can try with the next one, so it's more resilient. Okay. But that means that I need to have a reference from the receiving bot That means that I need to have a reference of the available storage of the bot that I'm following. Not of my own bot. How am I going to get that? So probably what I need to do is because at the file, we are putting the container ID. Okay, we're putting the container ID. That means that at a certain file, if I had that container ID, I could get the file. So because it's a file keeper file, that means that I might receive more than one signal belonging to different files that have the same information. Okay? So that puts me into the problem of what to read and decrypt in order to not getting the same kind of the same thing. Because I already got the same thing. Once I can retrieve it from one place, then I don't need to retrieve it from some other place again. Okay? So how am I going to prevent that? we will have to create an ID. Okay. Here we are saving. Save one file, but the file can be saved at multiple places, right? So the file can be saved at multiple places. That means that we're going to create one more field here that is going to be the file ID. File ID is going to be unique among all the files that I save at different places. It's going to be the same file ID. Okay. The file ID is something that we need to create, like here. So I need a unique ID. Unique ID. Foundations, SA, utility, miscellaneous functions, generate unique ID. This is what we need. So we're going to include a file ID. Okay. And also we have a storage container ID. But that means that we will need, because let's say we want to we receive here a signal, we want to load it, and we cannot loop through this guy because we don't have available storage. What we are going to have is the file ID and also we're going to have the container ID. So we need a map. Once we have the container, what do we do with the container? We make a GitHub storage load file. What is this? It's an open storage project. GitHub storage load file. I give the storage container, takes this from the configuration, and that's it. Okay. So I need to have available a map of in fact we need a map of all the nodes of the profile. by ID. Okay, so let's recap. We have two problems. First, we don't have a way to get a storage container because we cannot iterate over this stuff. Okay, so this iteration we have to redo it. Then we need to identify that if we already loaded one file key, we got a signal receive, and we make a load file. And the file we already have loaded before, then we don't need to redo all this procedure. Okay, so those are the changes I need. So to work on the first one, I will need to go to the network project and check out a guy that is called user profiles. So as to now, okay, open project, no, network project, this guy, user profiles. The name probably is going to change because this is doing much more than user profiles, but one of the things that this is doing is loading information into some memory maps. Okay, so these memory maps, I'm going to move this like to another section like here. These memory maps are this user profiles by user profile ID, blah 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 blah. So we will need another memory map with the storage container, so that when we receive a storage container ID, we can have that node in memory. Okay, so let's take one of these. So as to locate the module of the memory map. Okay, this is the module. So what we were saying is that we're going to need a storage container map by ID. Okay, so this is what we need. Storage container by ID. Okay, so at the place where we are identifying different type of node and adding them to this map, let me see how we get this done. Node branch to account, signing accounts. So these are sign-in accounts. So we will need something like this. Then I will come back one day and put this in a better shape. But here, containers, storage containers. This will hold storage container objects. Storage container objects. But it's not, I don't need to scan the whole user profile because these can only be defined here at user profile dot of user storage. Okay, dot user storage. So then we can iterate this guy for that is going to be more or less like this. Okay, and finally we are going to store at this memory maps, but in this case call storage containers by ID. We will put not this but this storage containers by ID. So we will take the ID as a key and store the node there, and that's how we have the storage containers here. Okay, so from this map is that we are going to return here. We don't need to run this. So it said that let storage container is going to be this get, and from the file key we will get the storage container that we put there at this property, the ID. Okay, so I'm assuming this is going to work and it's not going to be undefined, otherwise it's going to crash because there is no detailed error handling here. Okay, so storage container. Now that I have the storage container, I don't need to do a loop here. I don't need anything of this. And my storage container is already going to be known. Okay, this I'm not sure I'm going to get this, but maybe I get it. The parent node because I'm supposed to have all the user profiles loaded in memory with their parents and referent parents, so I can navigate all that information like easily. Okay. So we're going to set a breakpoint here. And as I have the storage container, I will have the config, blah, blah, blah. Okay. So that's one thing, one of the problems. The other problem was, how do I prevent this for reading the same information more than once and processing the stuff more than once? Okay, so what I'm going to have here at the open storage, because this is a mechanism of the storage itself, open storage client, I will have a map hold on. Yes, I will have a map. Let, how did I call this? File IDs. Files loaded by ID map. So here you're going to undefine this. This is going to be a new map. And every time we load one file, we're going to set file key, file ID, whatever, true, meaning that we loaded. Okay. So on the other side, before going through all this, I'm going to put a comment to know what we are doing here. We are going to remember that we already loaded this file storage containers. Okay. So we're going to say if equals true, and here we're going to have a get. So if we already loaded, file loaded by the map, get this file, then we're going to return an object or return, not an object that is going to cheat anybody, just return. So here we are going to control this file was not already loaded because the same file can be stored at multiple store container proceedings. We are going to load the first one and the rest are going to ignore the load request. Okay, so that should be enough. And also when we are here trying to load this, we will see that if I God is undefined, that would mean that we not need to return from here, because this is the situation, for example, happens when the signal was already loaded. Okay. Bueno, okay. I think I got it all. I'm going to put a breakpoint here, and we can try this again. Wow. Okay, so remember we changed, now we are sending a file ID. We have that mechanism, and also we are storing a map. So here, when we get the storage container from the map, this should work. And also we're going to put a breakpoint here. Okay, let's run it. Okay, this guy is running. We will stop this guy and debug this guy. Okay, so we can run this guy directly at Node.js. We can run this guy. And we will receive the signal. We move it to here. Jump here. Okay. So here we go. file ID. Do we have a file ID? Yes, so that's good. Do we need to return? No, because we haven't loaded this before. Next. The next thing is if we can get from here storage container. It's good that it has at least one guy inside. That means that we have, yes, and we have the parent node and we have the a reference to that node, which is awesome. So the file content is declared. The parent node is going to be this guy. We have everything to load the stuff. Okay, in the meantime, we receive the second guy. Okay, encrypted content. We got something there. Decrypted with the password. And we have our information. This file ID C4 gets into the map and break and return the file content. Then this guy continues there, want to continue. But we are here, the file content is not undefined. So we parse it and we got the file with the content and a timestamp. The timestamp was mostly for avoiding generating the same hash if there is no content. Okay, so records loaded. We called this the other day, we called it, well, doesn't matter. So here we have the array of candle signals. I'm not sure here where we are. I think that first is is an array of candles. This is a single candle. Okay, let's continue. Trading signal message. How many are here? One signal message. That's a little bit strange. Okay, but we have a trading signal message. Source. Trading system. No, blah, blah, blah. Okay, trading signal message. This might be outdated because I don't know, but maybe outdated. Source, trading system, node, candle, begin. Okay, the key is this. Trading signal message received. So signals. Okay, so it's going to store it. Okay, this just stores the signals in maps so that when we request it from the trading system, then we can retrieve them from there, from these maps. So this looks working except for the fact that I've seen only one signal, which is a little bit strange. Let's let it run. Maybe because I received the last files first, which would be a problem because that means that I can mix things up and have, well, it doesn't really matter because the bots will wait until it has the next signal of the candle he's standing at. So if something else comes first upwards, then it will need to wait anyway. So let this run, and here we have file content. Okay, here are all the signals that I was waiting for. So from here we parse records loaded. These are candles, or how do we call this when we save them? Let me check. Outgoing trading signals, outgoing candle signals. Candle signals to save, that's how we call them. It would be candle signals to lower. Okay, there are going to be, well, 19 candles, and for each one it has 9 signals, which is more or less what I expected. And for each signal received, we have the trading signal here with all the stuff: source, signal definition, trigger on signal. Okay, it looks good to me. I think we are done. I'm going to replace this, and we will go back here and remove this line so that it fully runs now. So our next test is going to be directly running both in Node.js. I have some hope that this is going to work. So we will come here and go to SuperAlgos folder. And going to delete from the platform, my data storage, all the trading information. We know that we are running the lightning strike, sending signals here and receiving signals here. So we are going to run this guy and run this guy. Now they are both running. Okay, so I'm going to run this first because it's going to essentially wait for the signals received from the other guy. So let's check it out. Okay, so it's going to get stuck there. Then I run the other guy. Okay, it goes pretty fast because their signatures are only at the end, so we are returning to the same kind of performance that we used to have. So there it signs one day, send it. Then second day and send it. And this guy is done. Okay, I don't see this guy doing his job. In fact, this is kind of stuck. Okay. But anyways, I can run this guy entirely and debug again this other guy to see why it's not working. Okay. So I think that we are going to leave it probably here now. We managed to close the circle debugging, and now we have everything connected as far as we know. Obviously it's not working. Let me check just in case something appear here. I don't need this guy or this. I will stop these tasks and check the charts. Okay, this guy had everything like normal. This guy doesn't have it. So okay, so again, we finish the work of debugging the whole changes we made to retrieve the signals and put it at the places where they were supposed to be. Okay, so all that workflow is working. The next step is to debug the workflow from the trading system when it tries to get a signal. It should get it once the signals are received and stored in those maps. So that part is right now not working. That is going to be the purpose of the next episode. And once we get there, we will have the second iteration of trading signals that is much more efficient, or is going to be much more efficient, resilient, and scalable than iteration number one. It's going to be very lightweight for the network because it's only one message per day of backtest in the case of daily files, or per whole market of backtest. Only one signal, only one message to go and grab the file with all the information from the outside of the network, like in a layer 2. And in the case of light trading, it's going to be one message per candle. So at the higher frequency, one bot would be emitting one message every 1 minute, which is kind of reasonable, totally reasonable, especially because there is no big information there. It's just a message that candle worth of signal is ready somewhere on the internet. Okay, so we are getting up to here now. Thank you for watching. Hope to see you at the next video where we are going to finish this stuff. Bye.